Okay. Chapter 8, builds upon what we were already talking about. I know that we kind of had a chapter 7 in there, which was arrays, and that kind of messed up. Arrays are objects, but we didn't spend a whole lot of time with like setters and getters like we did in chapter 6. And so chapter 6 was kind of the start of it. And then we have chapter 7, which was kind of off track a little bit. And then chapter 8 really adds on to chapter 6. So really, if I could rearrange, I would put chapter 8 right after chapter 6 and chapter 7 before. But because it's objects, I do understand why your author did that. But I think it kind of makes it, we have to go back and kind of think about what we did before. So if we think about the setters and getters as the foundations, the template for setting everything up. So we talked about something known as encapsulation. And so whenever you go for like an interview for programming, one of the main interview questions is what are the pillars of object-oriented programming? And so you should probably know what those are after this class. But the very first pillar is encapsulation, which is what we talked about in chapter 6. That's basically setting up the template for creating an object. So you have setters and getters for being able to change those fields. And the reason why you have those is because the fields are private, so you can't access them. So they're encapsulated, and you have to have setters and getters to be able to access them. And so that is the first pillar. The second pillar, we're not going to get to till chapter 10, which is inheritance, and then polymorphism, and that's all in chapter 10, unfortunately. But this kind of builds on what we were talking about before. So it's going to review the setters and getters and the constructors that we talked about, but it's also going to talk more about, what are static fields and what is a two-string method to make it a little more efficient. And so that's what this chapter is pretty much about. It's going to talk about something called aggregation, which isn't usually considered one of the pillars, but it's an important concept. But okay, so we talked about this rectangle class, and it had a length and a width. You can think back to the fields, and remember, each object had its own length and width. Can't talk today. And then you had methods to be able to change those because they're private. Okay. But we talked about static a little bit, but in that chapter 6, we didn't really have static because everything was an object we were working with. So if we're talking about like a rectangle, we want to be able to change the length and the width, then those aren't static. They're not static fields. They're not static methods because they're working with an object. So anything that belongs with an object is considered non-static, and we don't write the word static. But if we have something that's static, like for example, the square root method is static, it belongs in the math class. So you're not creating an object in order to be able to use that square root method. But when you use a method on an object, you have to say the name of the object, then the name of the method, and then do something with that object. So you have to create an object first. Like you can't change the length of a rectangle without having a rectangle. You have to create one first. You have to have the object. Then you can say which object you want to change the length of. Then you can do that. But for this, you don't create an object. You just say math.square root, and it goes to a file out there, a class out there called math, and it looks for a method called square root. It takes the 25, gets the square root, and it gives it back to you. And then it saves in a variable called VAL for value. Everybody okay with that so far? So when you do a method, it's either going to be static or non-static. If it's static, it's done in a class. And if it's non-static, it's done on an object. That makes sense, everybody? Okay. All right. So we haven't really dealt with static fields before. So what's a static field? So if you wanted to have these rectangles, right? And they have a length and a width. The length and the width makes sense that it goes with the object. So they're non-static because it goes with the object. So each object has its own length and width, right? But if you wanted to have a static field, if you wanted to count how many rectangles you have created, that would be a static field because each rectangle wouldn't have its own counter because then it would all be just one. Each one would have its own counter, and then they all just would be one. But if you wanted to know, hey, I created 5 rectangles, then that variable is a static field that goes with all of the rectangles, not with one particular rectangle. So it doesn't belong with an object, it belongs with the class of rectangles. Does that make sense, everybody? Okay, it's usually used for counters. That's like if you're working with object, it's good for counting the objects. So this is the same example that they have here. If you want to know how many objects you have, then that field shouldn't be for each object. It should go with all the objects. So it goes with the class, not the object. So you just put the word static on your field, and then it knows that it goes with the class, not the object. Okay. So we can have static methods. We've done this a lot. when we were first starting, we did all our methods were static because we weren't creating objects. A lot of the ones we used in Java were non-static, but the ones we created were static. And so this is an example of a static method. Again, you see the word static there. Whenever we have like setters and getters that go with an object, they're non-static because they go with an object. But if you're just creating a method that calculates something, if it doesn't have to do with the object, then it would be static. If it's not using like object fields and things. Okay. So remember, static means class level and non-static means object level. Everybody with me? So a field is static, then it belongs to the class. If a method is static, it belongs to the class. If it belongs to the object, you have to say what object you're dealing with, and then the method or the field you want to deal with. Okay? Just like you can pass, primitives as arguments, you can pass objects. You've actually already done this. You pass strings probably all the time. You've passed arrays. We did in the last chapter. Arrays are objects. So if arrays are objects and strings are objects, we've already passed objects. The only thing you have to be careful of is when you're passing objects, you are referencing the object. So when you change, if you change the array in your method, you change the original array. And so when you pass, so if you're passing primitives, you're passing by value. So if you had a variable here and a variable here, and you were saying pass it, you're passing a copy of the value, not a reference to the variable that has the value. But if you're passing an array, for example, which is an object, you're pointing to the array. So if in your method you make changes to the array, you change the original array. And we had this problem we were talking about, like copying arrays. If you said, I have this array I want to create, and you gave it all the values, and then you say, I have this second array, and I just want to say the name of this array, it would just copy a reference to it. And so then you would, if you made changes to the first one, it changed the second one. So you have to be careful. So you have to create a copy by going through all the values of the array and putting a new array and not just pointing to it. So you have to be careful when you're passing an address to it. So same thing if you were passing like a rectangle as passing an array, if you make changes in that, and this one we're just printing, so you're not making changes, but if you were to make changes to that length and width inside of that method, it would change the original rectangle. So just be careful. So we talk about like copying the object if you don't want to change the original one, but it depends on what you're doing. So just like you can pass in objects, you can also return objects. And so your return type can be an object data type. And if you're talking about like something that an object you created, it would just be the name of the class. Like the data type would be the name of the class that you created the object with all the setters and getters and fields and everything. Does that make sense to everybody? Okay. So this is just another example of returning. When you return it, you might want to create a new one of it. When you pass in, you might want to create a copy of it by actually pulling out the values. One thing that we're going to focus hard on this chapter is something called a toString method. The toString method is basically just a nice way to print information about the object. So you might think, okay, if I just have length and width, it's really not that big deal for me to say length and then put like get length and then do another like system out print line width and then print like the get width for that object, and that's not a big deal. But what if you had like 10 fields that you're talking about and you had to keep doing that for everything? That would be a pain. I mean, I know you can copy and paste everything, but basically what it is toString is a way for you to put a printout of all the fields and what they are, and then format if you want to format. So let's say you want to format the length to have 2 decimal places or width to have 2 decimal places, or if you're printing an amount, it to be a monetary with the $ sign and everything. If you want to do formatting, you do all your formatting and everything in this toString method and print it the way that you think looks nice. And then if somebody says that they have an object and they say .toString, it'll actually call that toString method and print everything. So they won't have to print and call each getter to get all the information. It's just a nice way to kind of print. You could have, so here's the thing. You're probably wondering, why is it called toString? Why isn't it called like print information or like print details? That would be great. And you could call it print details or print information, but the nice thing about the toString is that if you, I know this doesn't seem that helpful, but it is kind of nice. If you put the object name, like if you said system out print line and you put the object name in parentheses, you don't have to say .toString. It implicitly calls it. And so it's kind of nice because It just kind of saves time, I guess, and it looks neater. But if you call your method print details, then you have to say the object name dot print details. And also everybody that uses, coding kind of defaults to somebody will probably have a toString, not something called like print details, because that's what was established as like a standard, is that when you are going to print information about the object, it's called toString, and that's why they have that shortcut where like you put the object name. So you can see here that if you had a toString method, you could call it this way, like you typically would. And this way, if you had like print details, you could put that here. But the nice thing is you could just put the name of the object and you don't have to put .toString. But the other thing is, it's kind of like your setters and getters. You don't have to call it like set length. But if you call it like change length or modify length, then somebody goes into your code and they look and they're like, like why? Like it's just weird. It doesn't follow like the standard, like everybody calls them setters and getters, and they all start with like lowercase set or lowercase get. That way, if I wanted to change the name of an object, I would automatically guess that it was set name. And if someone goes and changes it to like, modify name, then that would be just like outside of the norm. I guess it would work, but it's just strange. So this is like the standard, and so it's kind of nice to be able to use that. Does that make sense, everybody? Okay. So you could, write more information about it here, but basically all you have to do is put the object name, and then everything that you put in there in the toString method, when you set it up for the formatting and everything, will print at that point. So hopefully in that case, there's only 2 fields, but it will print the information, the name of the stock and the price. Okay. So if you don't create a toString method, it has one by default. So we're going to talk about this in chapter 10. Some of chapter 8 won't make complete sense until we get to chapter 10, but if you can think of it this way, in basic terms, Java has inheritance, okay? And you know what inheritance is because you inherit things from like your parents, right? Okay, so hopefully you heard of the word inheritance, but Java only inherits from one class, okay? So when you think about it, your classes all inherit from other classes. You just don't know that they do because it doesn't say anything about it, but it does. So every class, you're creating object inherits from the object class. There's like a basic object class, and that basic object class has something called a toString method, okay? So if you don't create a toString method, it uses the default one that inherits from. And what it does, it just does this basic thing where it gives you the name of the class and the memory address of where it's saved, which is probably not what you want. But if like somebody puts system out print line and they put the name of the object or they put .toString and that person didn't create a toString in their class, it will print the name of the class in the memory location. And then you say, oh, there was no toString because it's using that basic object toString. So that's what that is. And when we get to inheritance, it might make more sense how that all works. But for now, as a general sense, does that make sense to everybody? Like that there is something, because it's kind of weird. It's like, how does it know what I mean to do by that? Because there's like a default out there, if you think of it like that it uses if you don't have one. Okay. So the equals, we have a problem with the equals. You've probably run into it at some point. When you use equal with objects, again, we talked about this, it goes based on reference location, not based on content of what you're doing. So if you had 2 arrays you were trying to compare with equal, it would not compare the values of the array. It would compare the reference location. So if they were saved in the same memory address, it would say they're equal. And if they're not saved in the same memory address, it would say they're not equal if you use equal. Yeah, but if you want to compare the contents, same thing with string. It wouldn't go character by character and look at the actual characters. It would just compare the reference locations. And so that's not really what we want. And so we can't use equal. Equal is perfect for primitives. Primitives are like basic integers, doubles, floats, longs, chars, booleans, but not strings, arrays, and all the objects we're creating. Okay. So we are going to create our own equals method because we have to tell it what we're comparing. So like if we have 2 fields, like a length and a width for a rectangle, we have to compare the length of this object to this object to say they're the same, and the width of this object to this object say they're the same. Then we can say the 2 objects are equal. But Java doesn't automatically look at every one of your fields. It doesn't have something that goes through all your fields and compares it to the fields of the other object to see if it's equal, if that makes sense. Because you can skip fields if you want to. Like you might say, something's equal, you know, if it has certain fields, even if it doesn't have all the fields. It's really up to you. If you want to, what do you want to classify as equal? Okay. All right. So again, you cannot do, let's say you have two stocks. Even though they're the same here, they're not going to be stored in the same memory address. And so if you ask if they're equal this way, it's going to see that they're not because they're not the same. The only way that they would be the same is if you actually just put stock 2 here instead of, you know, you were just using the same memory address. Okay, so the equals method for that would look like this. You would make it public so you can access it. Your toString and your equals are going to be public because you won't be able to access them otherwise from somewhere else. And we're always going to be in another file, so we need to be able to access it. So Boolean means it returns true or false. And so if they're equal, to return true, and if not, it'll return false. You're not going to put the word static because we're working with objects. We're comparing two objects. We're always going to call it equals all lowercase. And then because you have to compare one object to another object, you're always going to pass in the second object, okay? Now, the second, when you pass it in, you have to put the data type of whatever the object is that you're comparing it to. So if you're comparing stocks, you put the class name here. That would be your data type for whatever your blueprint was for creating the stocks. And then this doesn't matter. That's just a variable name. You can always just call it object2 for whatever type of object you're comparing, because it's just going to be what you use in here for comparison. So here you can see if the symbol, now you might say, what is the symbol? The symbol is the stock that you call the method on. That's like the active stock. And then the one here is object2 symbol is the one that's being passed in. So we talked about this a little bit before. And so you're actually comparing, and because the symbols are strings, you can't use equal for that either. You have to use the equals method. And so for this, because the symbols are strings, this is comparing the one symbol of the one stock to the other symbol of the other stock. Does that make sense to everybody? And then not only does that have to be true, but this has to be true as well. The prices have to be the same. Although I don't think you can have the same symbol. No. I don't think you can have the same symbol, but we'll compare the price anyway. So compare the same price to make sure they're the same. So this would be the price of the active object, and this will be the price of the object coming in. Okay, and if both of those are true, then the status up here is set to true. Otherwise, it's set to false, and then it returns it. You could just put return true and return false here, but a lot of times in programming, it's better practice to have a Boolean that is set and then return it after instead of putting a bunch of returns in there, because the returns can mess you up, because if you don't put an else, Java will complain that you don't have a return, because if you have a possibility to get out of a conditional without having an automatic return, like something that has to happen, like a default, like an else, or a switch with a default, or something at the end that says, you know, set it at this, it'll complain. Okay. Now, if you do it down here, then it'll be fine, because by the time you get there, then you'll have a status. Now, you might want to set the status at true up here or something, just to have a default. Yes. Yeah, no, that's fine. It's kind of hard to see without all the codes. So I'm going to show you later the codes, because this is kind of hard to like think about. But imagine that you have two stocks, okay? Two stock objects. I know you don't see all the code, right? And you have to compare them. So you would actually say something like this. Let me see if I can do this on Notepad without having the whole program, because I think I do have the program somewhere with that code from your book. Okay. So imagine I have two stocks that I'm comparing. I think I actually had some over here. Cool. I have these two stocks, right? Let's put them here. Okay. Stock 1 and stock 2. Okay, they're different, right? Okay. So I have stock 1 and stock 2. Okay, I'm trying to compare. So if you look at this equals method, because I had stock 1 and stock 2. Okay, so I need to compare these two stocks to see if they're equal. So the way I would actually use this in my main method when I'm trying to actually do it is I would say stock 1, because it's nice to have an example to work with. dot equals, and then I would put stock 2 in here. Okay, now when I'm doing that, what happens is it will call this equals method on stock 1. Okay, so stock 1 would be this. Now, also imagine that you have a stock class that has a field in it called symbol and share price. Everybody imagining that? Okay. We have a field called symbol and share price. Okay, so those two fields. So then when I say symbol, it's actually this dot symbol, if you wanted to write the word this dot symbol, but it's actually the symbol of that first stock because it's called, this one is called the active object. Whatever one you call the method one, so the one before the method name is called the active object. It's always referred to as this or just the field without the word this or the method without the word this. You can always put the word this on there, but you don't have to. And so your book chose not to in this case. It just says symbol. So symbol would be the field of stock 1. Does that make sense? Okay. And then you're comparing it to see if it's equal using the equals method because you're comparing two strings. So different from this equals method, but comparing two strings. Are you with me? Okay. To object 2 symbol. So object 2 is this one here, and actually that's a mistake. That should be in a lowercase o. Sorry about that. That was totally your book, right? So stock 2 actually is passed into object 2. Okay, so then when you say object 2, which again, that should match, that should have the same capitalization, then you're actually talking about stock 2 symbol. Okay, so what you're doing is you're trying to compare the symbol from stock 1, which is this right here, to the symbol on stock 2 to see if they're equal. And they're not, but if they were, if I would have left it the way it was before, if they were equal, then this little part right here would say true. And then if that's true and this is true, then it's true. But if one's false, then it's false. So in this part, same thing, like the share price is the active object because it doesn't say, but you could say this dot share price. And that might help you kind of identify that's the active object. Some people use it and some people don't. To me, it doesn't matter. Like if you like it, if you don't like it, you can leave it off. I know some people don't like to type extra things. They don't have to. So it doesn't say this dot share price, but that's what it would look like. And then that is the active object, which is this one. So you're talking about, when you say share price, you're talking about the share price field from this stock. And you're comparing it to object 2. Again, the capitalization is incorrect on there because that's an object and it should match this one. And so this is why the capitalization is hard, because when people do, like even if I capitalize this one, it looks like a class. And then that irritates people because then it looks like a static method, not a, because if you're doing it on an object, it should be all lowercase. And if you're doing it on a class, it should be capital. And so it's confusing, like, is this a class or an object? Or yes, you can like still use it if you capitalize it incorrectly, but I couldn't actually, this would be syntax because it's lowercase here and capital here. So one of them needs to change. This one should be lowercase. So this would be the object coming in, which would be the stock 2. And then that would be the share price field of stock 2. And you would compare them. And if it's true, then it would return true. But instead of doing return true here and return false, it's going to just set this variable at true or false and return it afterwards, which I think is usually considered better programming style, because that way you don't forget to put a return, or if you don't have an else, you don't miss, you're not missing a return. Does that make sense to everybody? Yeah, sure.
So the if stock dot equals parentheses stock 2 dot symbol, is that the symbol like the field, or
it's a field? Symbol's the field, but it's not always going to be stock 2. It can be whatever stock. Like if I had 10 stocks, it could be any of them. So generically, we always just call it like object 2 in there or something generic. So when you pass, this is taking this reference to this object and passing it to here. So in here, it's referred to as object 2, but it is stock 2 because that's what I put in parentheses there.
Oh, because you called out the method, but they're not. Okay.
Yeah,
it's like, why are you putting stock 2?
It's missing lots of pieces. The slide only has like one section. It doesn't have like the whole class with all the fields and everything. And then it doesn't have the main method that does the calls to it. So that's why I was trying to put some of the pieces together. So like this would be your main method. Just let me get rid of that because I was just trying to explain that. This would be the actual call that does like that brings back the true and false. And so ultimately, this would return true or false, and that's what you would print, like, are the objects equal or not equal? And of course, I would need that in like a system out print line that says like the objects are equal, or the objects aren't, and it'll say true or false. Okay, sorry about that. Yeah, when we have all of the code, I'll go through all of it, but sometimes slides are nice and sometimes they're kind of tricky because it, especially with code, you can't fit it all on one side. And your book likes to take one slide and draw it out into 10. Like, it's like, how many slides? 80 for like, I have to delete some of these. But no, I didn't even get the option to come with all. I probably need to try to like paste them all in there. But okay, so we were talking about this problem before. Sometimes it's okay to reference an object. It's not always bad, but sometimes it causes problems. So like just a general situation. If you're thinking about it, like objects can change, right? Like we think our name doesn't change, right? But sometimes our name can change, like if we get married or something. So when I first started here, my last name was Wrigley. Okay, and I was in the system as Wrigley for like a year, and then it changed and now I'm Daly. But when you think about it, do you want, when you change the last name, it to change everything? Like, do you want everything to then change to Daly, like so that you can't reference my name as Wrigley anymore? Or do you want, like, it depends on what you want, right? I mean, because if you want to go back and reference, like if someone comes and said, oh, I had Professor Wrigley, I wouldn't, like if it all changed to Daly, it wouldn't find me and be like, oh, well, that person doesn't exist, right? So, it can cause problems if you're always like changing the object to the original. Sometimes it's good to have a copy. And so when you make changes, it doesn't modify old things that happened. Like same thing, like if you're talking about, we have an example, I think, that'll work with this, where you have like a police record and like let's say you get a ticket under a different name or something, and then like it doesn't show up, or because if you change it, everything changes. So you have to be careful when you're changing things. Usually you probably want to have a copy because you don't want to override the things that you had before and then you can't reference them anymore. You don't have that information. Okay. So we can do different types of copies. So I'm gonna show you that when we have our actual code. Okay. So when you do it, again, this is like what we were doing before. When you're passing, oh, there's so many errors on this. It's driving me crazy. Can fix that one. No, maybe there. Can fix it so I don't forget. There we go. Sorry. Okay. I can't deal with that. Okay. So we have an object 2 being passed in, and then if you wanted to copy it, you can say like the object2 dot symbol. You want to put that in the new symbol, and then like object2 dot pres, but you're referencing it. Okay, so I have an example that I'll show you that makes complete copies of everything, where you actually create a new object. Okay, aggregation, a really easy concept, but maybe a little bit tricky code, but not too bad actually. So everything we talk about usually isn't as simple as just like one thing. And so sometimes we might talk about like a car and it's just like the whole car, but when you think about the car, there's parts to the car, right? Like inside the car, there's a radio, and then that radio has parts. So we say like has a relationship, but in code, like what do we care about? Like, do we care to break it down anymore or not? Like, do we just care about the car? Do we care about the radio? And if we talk about the radio, do we care that the radio has like different knobs and that kind of thing? How far do we want to break this thing down? Okay, so like you would say like a house. Okay, a house has windows, a house has doors. Okay, but then that door has parts as well. So do you need those parts or not? Like, are we interested in that? So when we look at this is a good, so it's called aggregation. So if we're talking about a course, for example, a course has an instructor and a textbook. And those two things have parts as well that we do care about, okay? So we're talking about a course like, for example, has a name, okay? But when you say a course has an instructor, you could just put the instructor's name there. But if you wanted more information about the instructor, then that could be a whole nother object, okay, with properties. And so these properties could be like last name, first name, office number, and whatever other details you want about that professor, right? If you just wanted their name, that could just be a field. It doesn't have to be an object. So basically, aggregation means that an object can have an object within it that has parts, okay, that has fields. And so, like the course has a name, but a course also has an instructor, and an instructor has fields as well. So the instructor is an object within the object of the course. Does that make sense, everybody? Okay, so you have aggregation as having an object, and that object has a field that is an object, which is basically everything in life, right? It's just a matter of like, how far do we try to break this down? Like, so in here, we have a textbook, and because the textbook has multiple parts, you might not just put the name of your textbook, but you might also want to have the author and the publisher. And so because it has multiple, attributes, fields, then that is an object as well. So this is an object, this is an object, and this is an object. But the difference is, and this is what the symbol in UML looks like, this shows a has a relationship, which means that this, see how this is strange? This instructor field is an object within that object. So if you look at it, you can see that the data type is the class name here. And then you have the object. And so same thing here. Except I do not know what is going on with my sides. That should be a capital T and the other one should be a lowercase. I'm gonna have to fix this later. It's absolutely driving me crazy with the capitalization errors. Okay, so that's supposed to be reversed. The data type should be the capital one and the object should be the, oh, okay. And then everything else is the same, except everywhere you have it, you would have like the constructor, you would just, the first one's easy, but then the second one would be that would be an object within it. So when you create the object, it can just go in that spot. It just has fields that you can access as well. Okay, is everybody with me? Except for the errors on my slides. Okay, I'm gonna have to redo these for sure. Okay, so you heard that word null before. Like we use it like when we do system out print line, we use null. Usually we use it because we're trying to skip something because like, we're saying like, oh, we're not going to answer that. And it just uses like the default. But you can have null if something isn't referenced. And so automatically if fields, I mentioned this before, but not sure if everyone knew what I was talking about. But if you have fields that are numbers in Java, fields automatically get initialized. The number fields with 0. But fields that are like strings or objects, they get initialized with null, okay? Which means they're not referenced, okay? So if you have an object that isn't referenced, then you can refer to it as like not equal to null, okay? It's not being referenced. And so it's saying if name is not null, which means that it is referenced, then we're gonna go ahead and print it out. But if it's not, then we're not gonna do that, okay? So you can check to see if things are null, but actually say the opposite. If it's not null, you want to do this. And so I don't know why I thought I had another slide on this. I don't know what happened to my garbage collection. Hold on a sec. Oh, okay. I don't know why that comes after that. I really have to redo those. But basically, another thing that Java does that's nice, that doesn't come with all languages, like C++, you have to do it yourself. It does something called garbage collection for you. So if things are not referenced, it'll free up that like if it's not being used, it's floating out there taking up memory, then it'll free up that space for you at certain points when it thinks that it needs to. And so if you have, like this is referencing that account 1 is referencing account 2 is referencing account 1. And so you can see they're both pointing to the same address. But if you take off the reference to like account 1 and you just say like account 1 equals null now, so it's not referenced. And then if you do the same thing with account 2 and you say equals null, then this is not being used and that can be freed up space. So a garbage collection will free it. So if something is not referenced, it'll come back and free it. Okay. And I could talk about this now and go back to what I was going to talk about because I don't really use these, but they're kind of helpful. It's kind of like pseudocode. You really should think out what you're trying to do before you do it. And whether you write that down as just like a list of notes or whether you formally have like a way you write your pseudocode, you just have to think about the problem ahead of time. This is a way, CRSC cards is a way for you to think about what you're trying to do before you do it. So think about the different classes that you're going to have and what are the responsibilities, what are they doing, and then trying to ensure you're not missing things, basically, just like your pseudocode. Trying to make sure you're thinking about it clearly before you just code, then you realize that that is not the way it's supposed to work. Like you're just trying to make sure you're not missing anything. But I need to fix how much I document and doing pseudocode and everything. But let's come back to this. So we talked about this, and we talked about this called shadowing. So shadowing is whenever you have the same field name and the same parameter name. So like, for example, this parameter name is the same name as the field name. And so the field for the class, you have to say this dot feet, because if you just say feet equals feet, it doesn't know which one. And it actually will let you go. But NetBeans most likely will give you a little warning. Because what it is doing, if you say feet equals feet, is putting the parameter inside the parameter because it just uses the parameter. It doesn't go to the default field. Because it doesn't know which one to make the field. Like it doesn't just say, oh, the first one's the field, the second one's the parameter. So you have to say this dot feet to refer to the field. Because remember, the field, the active one is this dot feet. Now you don't need to do that if you just don't make that parameter name the same name. You don't need to say this dot feet. But if you make them the same name, you have to, or you can't. It won't work. Like if you did this, you have to do it that way. There isn't any other way to do it because you made them the same name. So Java doesn't know which one's which. Does that make sense? Okay, so a lot of times this is optional, but in that case it's not because you named them the same thing. Another time you can use this to be helpful is if you already had a constructor. So we talked about overloading, which means you can have multiple methods with the same name, right? So you can have like a stock constructor and then you can have another stock constructor, but the difference between the two might be the number of parameters. So like one might have 0 parameters, one might have 2, one might have 1, right? How does it know which one? Well, when you call it, when you say that you want to create an object and you pass in the arguments for that object, it counts how many and it matches. It's called binding, but it counts how many it matches the one with that constructor with that many parameters, okay? So if you create an object doesn't have any parameters or doesn't have any arguments, matches the one with 0 parameters, right? Okay, so if you have a constructor and you could just go to the fields and say like set this field at 0 and set this field at 0 like we did before. But if you knew that another constructor had that and you just want to use it, you can call the other constructor by saying this and pass in this one and then pass in the other one and it'll set that field at 0. Now, I mean, are you going to do that? Probably not. But I mean, it saves some time because now you don't have to like set the symbol as the symbol and then set the price as 0 because now you're sending it to the other one. Now, what's the difference? The other one has 2 arguments, 2 parameters, I should say, and this one has 1. See how this one has 1? So when you called it, you have, if you want to use this one, you have to send in 1 argument. Okay, so you didn't send in the price. So this is saying like, I want to create a stock with just a symbol. Okay, so then this one says, okay, I'm going to take that symbol and send $0 to this other constructor, and it's going to set the symbol and the price as 0. Does that make sense? But you could just set the symbol and the price as 0 here. Like you don't have to send it to the other constructor, but this is kind of a cool, you'll notice programmers like to condense, and that's why I think the newer versions of Java, the JDKs, you'll notice that they condense a lot. Like the switch has arrows now, and like just like I feel like we're like trying to get less and less code. And if someone does things in like 1 line of code that would have taken 10, it's like that is really cool. Like it just saves, I guess, lines of code. Basically, does that make sense? But it works the same if you were to just see like this dot symbol equals symbol or whatever your thing is, and then say price equals the price. But it is kind of cool. Does everybody understand that? So if you put this and you put the parentheses and you have to have a stock constructor that has 2 parameters in order for that to work. And if you do, then that'll send that data there. And I probably should show you some examples because it's kind of hard to visualize, but hopefully you have a general idea. The other cool thing, we're not going to spend as much time with it because I don't think you do it too much, but it is cool to know. There's something called an enumerated class. Okay, it's called an enum. Basically, if you know that you're going to have this list of things, you can create an enum with it, and that stops people from adding things that aren't part of the enum. So like if you wanted to ask someone for a day of the week, if you just ask them for a day of the week, they can misspell like Wednesday, for example, and now Wednesday gets in there misspelled. Or maybe they put something that doesn't exist. But if you give them an enum, they have to put one of the choices. And so it forces to be one of the choices. So like this is an example. You just put enum and then what you want the name to be, like day, for example. Then you put all the choices. And because they're constants, they get all capital letters. And you just separate each one with a comma. So it gets curly braces. It's like, it's basically a list. Okay. And then when you want to use it, for example, you would create an object of that, and then you would actually say, okay, what's the class? And then which one did I want? Now, when you say day dot, it's actually going to pull a list for you in NetBeans. It's like when you say day, it's going to pull up all the options, and you can just double click on whichever one you want. Okay. You can make it as a separate class, or you can just add it to another class. You can make it a whole separate thing. Okay. So it's its own class, but it could just be put in a class with another one. So you don't have to, because creating another Java class just for that one little thing, sometimes people just put it within the other one. So I'll show you both ways of doing that. But there's, the way to access it is to say the day, and then it'll pop up with a list, but you can also, start typing and it'll come up with which one you want. I already talked about garbage collection, so I think we're good. All right, so I want to show you some code because I think it's hard sometimes if you're just talking about it with slides, and I want to show you something. So I have this, hopefully a lot of this makes sense because this is review of what we did before, but I have this circle class. So we switched to circles instead of rectangles. So the circle class only has, one of the problems though, is it only has one field. So it's a little bit hard to like do a toString with one field, but that's okay. So we only have one field. Your fields, unless otherwise noted, should be private. Like unless there's a reason for not making them private, they should be private. This is a double, so it's going to be a decimal. Then there's one constructor for the circle. It has to match the same name as the class. And then you're going to pass in the diameter, and it's going to set that as the diameter. Did not use the same name, so you don't have to use the word this here. There's no option to create a circle without having a diameter because there's no circle constructor that doesn't have any parameters, so you have to pass in the diameter when you create a circle. So if you want to look at that first part so far, this is an example of creating two circles, which is setting two different diameters. Now they could be doubles, so I could have put decimal numbers in there, but integer is fine too. Everybody good so far? Okay, perfect. And then this is review. You have a setter and a getter. Set diameter. Setters don't return anything because they just make changes, so you just pass in the diameter. You might say, well, you already set the circle diameter when you created it. That is true, but if you don't have a set diameter, you'll never be able to change that circle size. So if you want to be able to change it, you have to have a set diameter because remember that this field is private, so there's no other way to change it other than through the setter. So once the object is created, if you eliminate the setter, there's no way to change that number. Okay. Now, if you want to know information about it, again, because this field is private, you cannot just say the name of the object.diameter and have it print the diameter for you because it's private, so you can't access it. But you can use the get diameter for that. Okay, everybody with me? Now, if this were public, you could just say the name of the object.diameter of the fields instead of the name of the method, and it would print it. On the other file, on this file, it doesn't matter because everything, public or private, it doesn't matter. But on the other one that I have that has the main method, if it's private, it can't be accessed. That's why you have to go through setter and getter. Is everybody following? Well, it's our encapsulation, right? Okay, good. So this is just using this equation. So like if you want to know the circumference of the circle, you can take, this is a static method. Actually, it's not a method, it's a property of the math class, but it's a static one. So it belongs to the class. So there's a class out there, a file out there called math. It's under Java lang package. And so if you ever want to know anything about it, you can go out to the Java docs and look for the Java lang package and look for math class. And there's so much in there that you can use. But pi is one of them, so you don't have to remember pi. So if you say math.pi, if you just say math dot, it'll pull up every option you have. And most of them are pretty self-explanatory, so you probably don't need to do much research. Like if you want cosine, it's like an option, or tangent, all those are out there. So this will pull the pi, so we don't have to remember what it is, and it'll multiply it times the diameter. Remember, we don't have to pass in the diameter. It's using the field that we have up there. Is everybody with me? So if I say get circumference, so the toString on this, and I want to explain this in just a second. You need to make it public so you can access it. You need to return a string because it's going to be a formatted version of what all the combination of all your fields combined with formatting and everything. So it should be a string. And then it needs to be called toString, and it needs to be written exactly like this or it won't work when you try to do the object name without the toString. Okay, and then all you're going to do is put return, and then you're going to put everything you want to return about the object. So like if you want to say diameter circle and then print the diameter, it's not necessary for you to say this dot diameter. You could just say diameter. So I could take that off of there. This is not necessary. And if you don't like it, you can remove it. And then circumference is going to put the circumference. Same thing with this. You can take that off if you don't like it, or you can leave it on there. So it's going to print diameter and circumference because that's the only two pieces of information that we have. It is getting the circumference from here. We don't actually have a circumference field. You have to call this method to get the circumference. Does that make sense to everybody? Awesome. Now, it doesn't do any formatting, but if you wanted formatting, you can add it in there. You can either add it the way that your book shows you, or you can use the decimal formatter. I like the decimal formatter, but you would just add the import for decimal formatter, and then you can just add the decimal formatting right to that method, and then it'll have 2 decimal places or whatever you want, if you want. So are you with me? So this is where you would decide how you want it to look and do it. And then that way, when you want to use it, I'll come back to this override in just a second. You would just say, ignore this right here. I'm going to comment it out. You can see this. Now, you don't have to say .toString, actually. You can just say C and C2. I'll show you in a second. But I can do it like this for now so you can see it. So if I say C.toString, it's going to call that method here to print all the information about that object, okay? So I don't have to say, you know, get diameter and get circumference because I thought I clicked run. Okay, it's just going slow today. All right, so this is the first circle. And see, this is where we would want that formatting. Maybe I can add that on there in just a second because that is kind of irritating. And then that's the second circle. That makes sense to everybody? So you can, again, look at that and say, I don't like that. I'm going to add formatting to that. And so all you have to do is come back over here and say like, okay, I want to add formatting to this. I'm going to use decimal format, but you can use something else if you want to. So you have to import java.text.decimal format. I like this one better, but you can use whatever one you like. And then I went in here to create a decimal format object. I'm going to call it pattern, for lack of a better word, decimal format. And then I'm going to put a pattern. It doesn't matter if you use zeros or use pound signs because it really just depends on what you like. Because if you want the zeros to always display as 2, you put zeros there, otherwise pound signs. Either way is fine. And then when you, the circumference was the one that was giving me problems. So I have to say whatever, I named it up here, pattern, that format. Now, sometimes this like is confusing, so you can move this if you don't like it. Basically, I'm taking the thing I had before and putting it inside of this format method. But if you don't like that, because it's like too many parentheses and all over the place, you can kind of do it step by step. So like if you didn't like that, you could take this out of here, for example. This is just an example. I kind of like to condense, but if that was too overwhelming and giving you a headache, you could take it out and you can say, okay, I want to create a circumference variable. So I want to create like a double C and I'm going to put it in there. And then I'm going to just format C. You could do something like that if that's easier to read, easier on your eyes, right? But this is the pattern that you create up here of whether you want zeros or pound signs. This tells me I want 2 decimal places, and if I don't have any decimals, it puts 0.00. But I don't really have a preference either way. You could just do this if you want. And then you put the name here, pattern has to match, and then the name of the method is format, and then this is what you want to format. So this is actually a non-static method because it's being done on an object. You're saying, what's the name of the object that has the pattern? It's called pattern. And then the method name is format. And what do you want to format? I want to format the circumference that I got from this method up here. I could just, again, take this and put it in place of C, but it creates a little bit more overwhelming. But let me try this now and see if it works, because before it was kind of a mess of numbers and I really didn't need that much detail. That looks a little bit cleaner, I think. But that's where you can experiment with this, because if you didn't do that, all of this code that you have would have to be in the other one, and you'd have to do it for each one of your objects. And see, that's the pain, because if you want to print data about this circle, even though we're only talking about 2 fields here, imagine that you had 10 or 15. If you're always wanting to know the information about that particular object, then you can just do it in one place. Like the toString is a nice place, and that way you don't have to keep repeating, like, I'm going to call the getter for this and the getter for this, and I'm going to format it this way, and then that's kind of redundant, right? It's pain. And so, and also, there's that little shortcut. I know it's not much of a shortcut, but if you call it the right name, like if you call it toString, you can eliminate the toString and just call it the object here. You can do that, and it knows to call the toString. That's part of one of the benefits of using toString, is you can do that. Now, if you change the name even slightly, and you decide, I don't like that name, I'm going to call it printstring, then the difference is that you can't, first of all, I have to talk about that in a second. I'll come back to that. I can't use this anymore. Now watch what happens when I do this. It's kind of interesting. Because I called it print string and I did change it here, this is going to use the toString from the object class that I was talking about before, because if you do it and you don't have a toString, it uses the object default. So this is going to go, and you would probably say, what in the world is going on? Like, that's not what I asked you to do. I asked you to print, right? But if you ever see that, that means that either maybe your capitalization or your spelling is wrong on your toString, because the toString isn't connecting with like the object. Like, it's not automatically calling the toString because it must have a different name. So it's using Java's default one. That's Java's default. If you see that, your toString's not working. Okay, that tells you that it's not working. And so this is like the memory address and the class name. So you can see they're in 2 different memory locations, but that's not really what I wanted. So it's because I called it print string over here. So if I want to use a different name, which is not standard, then I can't use the shortcut. I would have to say dot print string. And it's fine. It's just not standard. So that's why, again, I know it's a weird name, but we call it toString. Everybody with me? And then that way that fixes this problem. Now, I did take off that overrides, and it still works. I want to talk about that briefly, but this chapter is not about overrides, and so I don't want to spend too much time on it, because we have a whole chapter on it, because it's pretty important. So this chapter talks about aggregation, and I don't want to confuse people with aggregation and inheritance too much. So remember, aggregation is like the important concept of this one. It's like an object can have a field that has an object in it, right? Inheritance means that I can have a dog, and a dog class has all the basic things that a dog has, right? But then I can have many dogs that are based off that dog class. And I can say in the dog class, dogs have 4 legs, and they bark, and they walk forwards and backwards, and okay. And then, like, a poodle is a dog, so a poodle can walk forwards and backwards and has 4 legs, and I don't have to keep repeating that. But like a poodle and a German Shepherd look different, right? That's like the basic idea of inheritance. Everybody has like a general idea. Okay, so the reason why it's putting the overrides on there, and NetBeans will tell you this little override annotation, is because there's the toString that Java automatically has for you that's in the object class. And so you're saying that you want yours to override theirs. Now, it does it automatically, so you don't have to put that annotation on there that it's asking you to put. But the nice thing about the annotation, there's a couple pieces. It tells people that you meant to do that. It wasn't an accident. Like, you meant to override the method. You didn't accidentally just give it a name that Java already had. But it also stops you from changing it. Like, if someone goes to change it, it won't let you. So like right now, I could change this to print string and it has no problem with it, right? It's like, okay, fine, because it doesn't override. You told me it didn't override. I don't care if you change it. But like, this is kind of cool. If you actually add, you can type it yourself, or you can, oh, it didn't. Oh, I didn't put it on there. There we go. It should be able to add it for you. You can click add override annotation. And the cool thing is it tells people I meant to do that. but also it won't let you change it now. So it's like, if you meant to override it, then that's a problem because that's the wrong name. Like it's not going to override if you put that name. And so it stops people from making a mistake and coming and saying, I don't like that name, I'm going to change it. And it's like, well, no, if you want to override, you can't change it. So it stops like errors. So in a general sense, is everybody okay? Did I totally lose? Okay, trying to stay as basic as possible, but sometimes Java throws some things in there that are beyond the scope of what we're doing, and it kind of makes it hard to move on. So, okay. All right, then we have this equals method. Is everybody okay with the toString method? Okay, perfect. So the equals method is again public because you have to be able to use it. It returns true or false, so it's Boolean. You always just call it equals because you don't want to make it tricky on people. Everybody's used to the word equals, so don't get fancy with it. Call it something else, like compare. Okay, let's call it equals. And then you always have to have, if you're going to compare one object to another object, in here has to be a parameter that compares the other object. And so whatever you're comparing, you have to put the data type of the object you're comparing it to. So if you're comparing circles, the data type would be circle. That's where it's coming from. And then this, you don't have to call the second one circle if that's confusing. You could just call it C, or you could call it object2, like we did in the other one, to stay very generic. Whatever you call this name here, though, you have to use when you're referring to the second object. Okay, so whatever, normally you don't call it, you could call it like circle2, I guess. But then it's kind of tricky because when I do that, then when students go over here, they see like C2, they always think it's C2, and it might be like C4, or it's, so I try not to do circle 2, but it's just a general name. Does that make sense to everybody? That's going to be used in your code. And then whenever you want to refer to the second circle, it's whatever general name you put here, and then the field name of what it is. Now the first field is always either this or just not this, just the field name. Okay, so you could just say diameter. You don't have to say this dot diameter, but there's only one thing to compare because there's only one field. So you're just comparing the diameters, and because these are two numbers, they're primitives, you can use equal equal. If they were strings, you have to use equals method, which makes it a little more tricky, but if they're primitives, you can use equal equal. Okay, so if they're equal, then it's true, and if not, then they're not. Now, in this case, we did use return, so there would be a problem if you took off that else. It would say missing return because even it might. But you could create a Boolean, like if you didn't like that, because I remember before I told you that it might be more proper to say Boolean status, something like this. Status equals true. And then return at the end. And then that way you don't mess something up by the if statement. It wants to restructure this. I kind of like it the way it is, but it wants to make it like this, which I think is a bit much. But that's fine if you like that. I told you, it likes to shrink things. So if you do this, if this diameter is equal to that diameter, then it's automatically going to say true, and it's going to put the status in there and return it. But if that's too confusing, then maybe you could put the if statement back in there. Does that work for everybody? But sometimes it's nice to just see what it's suggesting, and then maybe it will make sense and you can just leave it because it is a lot less code. And if it makes sense, you can leave it like that. So it's really up to you. But does that make sense to everybody? Okay, so equals, if we go over here to test it, I have this line. You have to put it in a printout to see what it says, because if you put it on by itself, it's just going to say true or false, and you're not going to see it anyways. So you have to say one object that you have, that's the first object, dot equals the second object, okay? And then it's either going to say true or false. And so they're not the same because one is 9 and one is 8, so it says false. But if you make them the same, then hopefully it says they're the same. So it says true. And you don't have to just have two circles. So I don't want you to think that you can only have two. You can have as many as you want. And this is why you have to know what exactly is going on, because if you're comparing here, you might compare circle 1 to circle 3. You don't have to compare 1 and 2, right? You can compare whatever you want. And that's why this name that you're giving in here should be generic because it's not referencing a certain circle, but it's generic that it can be any circle. Like this one happens to be the third one. And so it's gonna reference the third one in that case. So that's why this is a generic name because it's not always gonna be the same circle. That's what I want to make sure everybody understands is that your methods have to be general because although we create objects to test it and have an example, there can be many objects and they can have different names. And so we're not referencing any of those particular objects. We're saying general. So it can be any object that can be referenced with that circle name. And if it's confusing to give it the class and the object the same name, it's okay because it's different capitalization. If it's confusing, then maybe just call it C or call it object 2. Maybe call them all object 2 or object if you want. Does that make sense to everybody? Okay. Now, on the tricky thing, if you're looking at this, you may have remembered when I talked about arrays and I said like if you use equals on arrays, it wouldn't work because there was a special way to do it. We don't know why they chose to do that, but there's a special way to do it. But every object has an equals method. But you're probably wondering, maybe you're wondering, why doesn't that one say it overrides? Because there is an equals method. So we're going to talk about this more in chapter 10 if you even were wondering. There's a different data type for that. It takes in all objects instead of taking in circles. It's not specific to a circle. That's why it doesn't override. So if you were even wondering that, it doesn't override because it's working with circles and there's no default one that works with circles, and that's why. But if it didn't have any, if it worked with objects, it would override. So we'll talk about that later, what that means. Does anybody have any questions about this? Okay, I want to talk about one more thing.
Gosh, there's on the file, so you had several delete or C3.
Mm-hmm.
For you to print that, you have to add more code to it, right? Like, can you so
Yeah, I just add the same thing. Here I could put, yeah, I'm not printing it. So I could put just like C3. And then I could compare. I don't think I ran it either. So this is the third circle. And then this is like, it was comparing circle 1 and 3, and they're not the same. Circle 1 and 2 are, but circle 1 and 3 aren't. I probably should put more in there to print off like what circles I'm talking about, but if you go back here, you can see just for testing purposes. But it's not real descriptive in the output to say what false and true are. But for testing, does that make sense? Does everybody understand this? This is the foundation for everything that we're going to do in chapter 10 and chapter 11. And chapter 9 kind of goes out on a tangent again. But it adds some cool features. Like there are some methods. It talks about like ways to break down your strings and talk about like parts of your string and how to compare and things like that. So there's lots of cool features, but it doesn't build as much. Like for me, the object-oriented concepts that you're going to learn are going to be chapter 6, 8, 10, and 11. The rest are just extra. Okay, that's where your final project is going to come from, 6, 8, 10, and 11, because the chapter 9 is just extra, like I can do cool things with my project now, but not really object-oriented concepts as much. But there are some useful things in there. I shouldn't say that completely, but for the most part. Okay, so if you understand this foundation, I think that's really good. So you can do probably like, at least a third of your final project, right? Pretty easily if you know this. So that's good. Everybody good so far? Okay. We're not going to talk about this as frequently, but I mentioned it in the slides, but a static field. I want to show you a static field. And the circle one is a perfect one to do it because we can count the number of circles, and I have 3, so I should be able to count that I have 3, right? So how do we do that? So if I go back here, and I only have one field right now, but this field is a non-static field, and because it doesn't say static, so that means it goes with each object. So each circle has its own diameter. Does that make sense, everybody? They all have their own diameter. Okay. But if you wanted to, you can, I'm going to make it private because private has nothing to do with whether it's static or non-static. Private has to do with how you can access it. Okay. If it's public, anyone can access it from anywhere, which creates security issues. I'm trying not to get you to do that. So most fields are private because you don't want everyone to have access everywhere. Okay. So we don't want people to mess with my counter. So I'm going to make it private. Okay. but it has nothing to do with it being static. Then I'm going to make it static because I don't want it to go with an object. Okay, I want it to be a counter for all my objects, not for each object. I don't want a counter for each object. Does that make sense? If I make it non-static, each object has its own counter. If I make it static, the class circle has one counter and that's it. So static means one with the class, and non-static means one with every object. Does that help? Okay, I know that that's probably one of the trickiest things with the class is static and non-static, but we're gonna get it. It's gonna be okay. So we're gonna put the word static on here, and then we still have to tell like what data type is it. So is it a double? Well, counter is usually int because it's a whole number. We can't have like a half of a circle, so we're gonna say int. Okay, and then we're gonna say counter, I guess. Whatever you think is a good name for counting circles. Count, counter. Okay. Everybody good so far? All right. Don't worry about the yellow. I didn't use it yet. Okay. So I have this variable. Now what I have to do is I have to think about how do I know when I created an object? Like how would I know I created an object? What's the method that tells me I created an object? That happens with every object you create. Anybody know the name for that? The constructor, good, okay. So every time I create an object, the constructor is automatically called, right? So if I create an object, the constructor will be called. And so I'll know I have one more object, right? So if I add my counter, if I increment it in the constructor, I would be able to keep track of how many objects I had, right? Because the constructor has to get called. The only problem I would have is if I had multiple constructors and maybe one time I called this constructor and one time I called this. So I'd have to increment in every constructor I had. But I only have one constructor, so I don't have that problem. But if I had two constructors, you'd have to be careful that each constructor had a counter. And it doesn't matter because when it hits the incrementer, it would increment. So it doesn't matter you have, counter plus plus on one and counter plus plus on the other, because when it hit that line, it would just say one more, right? So if I had another constructor, which I don't, I would have to also put this code in there, but everybody's with me, right? Okay, so it doesn't matter where you put it because it just has to go in the constructor. You would say you want to increment that counter. So we just say plus plus. It doesn't matter if you say plus plus counter or counter plus plus because it's on a line by itself. So it doesn't really matter. You can't say counter plus one though, because that doesn't replace counter. You have to make sure that you say counter equals counter plus one or counter plus plus because you want to replace what the counter is. You want to take what was it and add to it and replace it. Everybody with me? Okay, perfect. So now we have a counter that's incrementing. So we should be good, right? We should be able to print it off. Okay. So I have a slight problem. I'm going to go back over here. I want to print my counter. So I'm going to do a system out print line. Okay. And I want to print total number of circles. Okay, and I want to print that number, okay? So to print that field, I would, because it's a static variable, does anybody know what I have to put first before the name of the method or before the name of the field? I can't just put the name of the field. I have to put what?
Class.
The class, good. What's the class name?
Circle.
Circle, perfect. Circle dot. Now, you notice that when I put circle dot, nothing comes up. That's because my field is private. Okay, if my field were public, that would be fine. Let me just take that off so I can show you. Then I could say circle dot, and now you see it. I could say circle dot counter, and I'd be fine. And I'm going to go ahead and print it so you can see it works, and then I'm going to fix it. Okay. Total number of circles 3, perfect, right? So you're probably saying, why do we have to keep making things private? Because it makes life more difficult. For security reasons, we try to get around that because it does make things difficult. Like if you wanted to change the diameter of the circle and the diameter variable wasn't private, you could just say the name of the object dot diameter and put equals and change it, right? And that'd be easier than having a setter to change it. That's methods that you have to have. And then you wouldn't have to have a getter to return it because if the field was public, you could just say the name of the object dot diameter and it would print whatever it is, just like I just printed that, even though it's a static field. So let me show you what I'm talking about, but then I want to show you why we do it. Okay, so if I take this off here, I'm just trying to show you so that everybody understands because it does make it easier if you don't do that. So if I wanted to change the diameter of a circle, let's say, and I wanted to say like C2 dot diameter equals 4. That's fine, right? But, and we don't have any validation on here, so it doesn't stop it anyways. But if I did, let's say I did put a negative number in there. It wouldn't have mattered before because my setter doesn't stop it anyways. But if I did go add validation in here, like if I did go to my set diameter and I said that if D is greater than 0, then set it, otherwise it'll be set at 0. And you do that, and then I also say, remember I did this as well. You can either put it up here or you can call the setter. For this is the same logic, right? I could just call the setter, I could do the same logic in there. That should stop me from getting a negative number. But if your field is public, it ignores that because you didn't use the setter and you didn't, and so it ends up being negative, right? Because you're just skipping to the value. You're not using the setter to change it. So that there's no way to validate the way that I have it now. If I have that field public, there's no way to validate it. And I know you're probably saying that I don't need to validate that, but okay. But it is important because you just don't want bad data in there. So it doesn't always have to be negative numbers. It could be a range. You could say, I want it to be a range from this to this. I want it to be a number between 1 and 10. And if it's not, I want to set it as a number between 1 and 10. Does that make sense, everybody? But if you leave your fields public, they're wide open to anything. Like if you have an enumerated type list that you have and you want it to be one of those, but you leave your field public, and it doesn't have to go through and get something. It's just that everybody can pick, whatever they want. Like if things are public, just think if things are public, everybody has access to and you don't want everyone to have access. Okay. So if I use the setter, then this wouldn't allow this. Like if I said set diameter to -4, then it's going to tell me no. It's because that's not an option. And it's not going to tell me no, actually. It's going to just make it 0, right? Because, and actually, it's not going to make it 0 because I already created it and it had 9 in there. So it's just going to leave it as 9. Now, it depends on what you want to do. Because if I did put an else set it at 0, it would set it at 0 because it would override what it had before. That's why I don't like putting the else, because I think if you created it with 9 and then you try to change it to something that doesn't work, like -4, then you should just leave it at 9, not put it back at 0. So I don't like to have the else on there. So it'll just leave it at 9 because it didn't change it, right? But if I say to change it and I don't have a negative number, then it works, right? If I say set it at 4, then this one's going to be 4, that second one, because I asked it to change it. So it changes it to 4. And it also stops me from creating a circle that has a negative number. And this time I'm going to take this out. It's going to make it 0 because it doesn't have an option, because I didn't change it and because I put a negative number in there and it says I can't have a negative number on the constructor. And so it should make it 0, right? So that stops invalid data. Does everybody get that? Okay. It's the same thing for this counter, because if the same way as it's easy to access here, this is easier than me having to create a method to return it. It's also easy for people to mess it up. If it's easy to access, it's easy to mess up, okay? So I can easily just go in here and make it whatever I want, right? I can say like equals -67, right? And that's not cool because now I just messed up the counter. Pretty good? Not cool. So easy access is not good, okay? So instead of accessing that way, I'm going to then set these back to private so that we have to go the right way. And then you have to find an alternate route, okay? So I would need to create a method, and it can be above the constructor, below the constructor. It just has to be inside the class. Java doesn't care about your order of your methods. The constructor doesn't have to be first. Usually it is, but it doesn't have to. I'm going to put it up here so you can see it better. I have to make this method public so I can access it, right? Okay. And then I'm going to return an int because I'm going to return the counter, right? But the thing that's strange is it doesn't belong with an object. So what word do I have to put on there? Static. Good. It's static because it doesn't work with an object. I don't need to know what circle you're working with to get the counter for all circles. Does that make sense? Like I'm not going to say circle 3, get me the counter, because it doesn't belong with circle 3. It belongs with all of them. And so it's static. And then I'm going to return an integer, and I'm going to call it get count, maybe, or get counter, whatever you think makes sense. And I don't need to know anything to get the counter, so I'm just going to leave that blank. And then I'm going to return the counter. That's it. Okay, this is just a way to access this, because I can't access it directly. I can get it this way. But that stops someone from changing it because there's no set count, because you shouldn't be setting the counter. So there's no way to set it. I'll show you how I can't set it now. But then when I go back over here, this little method is my way to access this because it's private. When I go back over here, it says I can't access it that way, but I can't access the field directly, but I can access the method that I just made. So I can say get count. Does that make sense? And then that'll give me the same answer as before. 3 circles. It's just accessing that field, just a different way. Now I cannot say counter and put a random number in here that's not good, like a negative number. It's going to say I can't do that. I don't have access to that. It has private access. And so that stops people from messing with your variable, your field. Okay. So if I wanted a set count, I would create one and create some validation, but I don't want people to set the count. I want the count to be automatically by the counter. So I don't even want to create a set counter. Okay. But so there is no way to change the counter, which is good. The only way to adjust the counter is to add an object. And the more objects you add, let's just make sure it's working. So if I add another object, it should say 4. It should keep track, because every time it hits that constructor, it should say you have another object. So it should say I have 4 circles. And then if I delete some circles, it should say I have 2 circles. So make sure it's working. Does that make sense, everybody? So I think that this is out in course notes, but if it's not, I'll post it. But I really think that if this is really confusing, I need to just go through it and kind of just make sure, of course, you have to understand setters and getters because we can't get past this point, but really understand the constructor and the validation to make sure that, and that the variables will be private and how we access them. So maybe play around with the public and private if you need to get that to make sense. But kind of take a look at this counter and how that's static, but this one is not static because it goes with the object. And so remember that the counter goes with the class. And so it has a different way of accessing it. So when you access the other ones, you put, well, I didn't really do much with them. Like if I wanted, I did the set diameter before, but if I wanted to do like C2 dot set diameter to something else, I know I did before when I put the negative and everything, but you have to say the object name and then you have to say the name of the method. But when you're using a method that is static, you put the class name, not the object's name. And if you think about it, it wouldn't make sense to ask for the count of an object if it goes with all objects, right? So it makes sense that it goes with the class, not with the object, right? Hopefully, okay. All right, so that was the main thing. I think, let me see if there's something I can do, because I have some time. I don't want to start, like some of these are bigger examples. I want to wait till next class to start. Let me stop.